In this video, we're going to be looking at propositional logic in discrete math. So a proposition is a declarative statement that is either true or false. So let's look at some examples of propositions, and let's actually see if we can identify what is a proposition and what is not a proposition. So I've put down two sentences here. Now I want you guys to figure out which one is a proposition and which one is not a proposition. So the proposition is number one, if you guys got that right, and the one that is not a proposition is number two. The reason for that is that number two asks a question. Right? What time is it? We cannot conclude this with either true or false. Well, for number one, we're stating Canberra is the capital of Australia. Now this can either be true or it can be either false. Now propositions are written commonly using letters P, Q, R, and S, right? But they can basically be written with any letter you like. But these are the common letters that you might see on your formula sheet or on your theorems, right? Furthermore, true and false can be represented by ones and zeros respectively. So if something is true, you can represent it with 1, and if something is false, you can represent it with 0. Now, let's look at the idea of logical connectors. Now, logical connectors are really important when it comes to when we want to write down a proposition, right? Or even understanding propositions in general, we need to know logical connectors. So let's start with our first logical connector, which is the negation. Negation just means not and is represented by this symbol over here. Kind of looks like a hand reaching out. Now let's look at the disjunction, which basically means or, and is represented by a V, or that's just how I like to think about it. A conjunction, the representation is opposite, but it means and. So it's just a V that's upside down, but it represents and. Exclusive or is represented by a circle with a cross in it, and what it basically means is either, but not both. Now conditional is known as then, right? It's basically just saying then, right? Whenever we see then, it means that we have a conditional, and basically is represented with an arrow. Biconditional means if and only if, and it's represented with an arrow with two heads, as we can see here. So that's an introduction to logical connectors. So let's use the logical connectors that we just learned about to create compound propositions and to understand them. So here we have P, which basically is defined, or it means it will be sunny, right? And we also have Q, which means that I will buy ice cream. So we have it will be sunny, which is defined by P, and Q, which basically means I will buy ice cream. So the first question says not P. So what is a negation of P? If it will be sunny, the negation of this will be it will not be sunny. All right? Now, the second question asks us P or Q, right? So this first one, what we did was a negation. The second one is a disjunction, right? So it just basically, remember, we said that it means or. So it means P or Q. So it'll be sunny or I will buy ice cream. It will be sunny or I will buy ice cream. The third statement says this, P and Q. Now this is a conjunction. So P means it will be sunny and Q means I'll buy ice cream. So it'll be sunny and I will buy ice cream. So the key word here is and. The key word here was or, and the key word here was not. So let's write this. It will be sunny and I will buy ice cream. So for question 4, we have P arrow Q. Now this arrow is important because it means that we have a conditional, And the key word for the conditional is then. So the idea would be to say this: if it will be sunny, then I will buy ice cream. Okay? Now, question number 5 states this. We have P, and we have an arrow with 2 heads. And remember what we said about that arrow with 2 heads? It means that we're looking at a biconditional. And the key word for the biconditional is if and only if. So we would write this like this: it will be sunny if and only if I will buy ice cream. Right? Okay, so that's it for number 5. In number 6, we have our exclusive or, right, which is a circle with a cross in it. So the idea behind that is that either it'll be sunny or I'll buy ice cream, but not both, right? So it'll be like this: either it will be sunny or I will buy ice cream, but not both. Right? So either it'll be sunny or I'll buy ice cream, but not both. So that's all for an introduction to propositional logic.